In this diagram, we can see a circle, and the radius is r, and we have this angle here we pronounce theta. What this is, what I've shaded in yellow, is what we call the minor sector of the circle when we have this angle theta, and the major sector is on the outside in white. It's basically the rest of the circle. The minor arc is the distance from one end of the sector to the other here, so following the circumference of the circle. And the major arc is going to be everything else, so the rest of the circumference. We can think of a situation like this just being a fraction of a circle. So if we want to work out the length of this minor arc, what we need to do is do what fraction of the circumference do we have, and the fraction is going to be theta out of the angle in the full circle, which is 360. So to work out the length of the arc, we need to do theta over 360 times by the circumference of the circle. And the circumference is 2 pi r. So we can think of this as theta over 360 times 2 pi r, or theta over 360 times pi d, if you prefer. Let's have a look at some examples. If we want to find the length of the arc in the first example, the angle in the center, theta, is 30 degrees. So I'm going to do 30 out of 360 times by pi times the radius squared. If I want to find the length of the arc in each of these examples, the first question, the angle in the center is 30 degrees. So I have 30 out of 360 times by 2 pi times 5, because the radius is 5. And I like to put the 2 pi times 5 over 1. And then we can see what will cancel out. So we can cancel the zeros here. 3 goes into itself once. 3 goes into 36 12 times. So we end up with 1/12 times 2 pi times 5 is 10 pi over 1. And I can cancel again. 2 goes into 10 5 times. 2 goes into 12 6 times. So we end up with an answer of 5 pi over 6 centimeters. Now I'm going to leave it in terms of pi. Well, there isn't actually a unit for the distance, so it's just 5 pi over 6. And I'm going to leave it in terms of pi. But then for the second part, so this is in terms of pi. And then if I want to give this to 2 decimal places, I can get my calculator. And I can do 5 pi over 6, 5 shift pi over 6 equals SD, and I get an answer of 2.62 to 2 decimal places. In the second question, it's the same sort of thing. So in the second one, I can do, this time the angle is 90. So I have 90 out of 360 times, and I'll do pi d this time. So pi times 20, that's the circumference. Cancel the zeros. 9 into itself goes once. 9 into 36 goes 4. 4 into itself goes once. 4 into 20 goes 5. So we actually end up with 5 pi. Which, when you think about it, makes sense because the entire circumference would be 20 pi. So if we divide that by 4, which is what we've got here, we end up with 5 pi. And if I want this to 2 decimal places, I'm just going to do 5 times 3.14 approximately. So 5 times pi, 5 times pi, and SD, that gives me 15.71 to 2 decimal places. And lastly, the angle is 120. It doesn't matter that it's obtuse, so I have 120 out of 360 times pi times 12 all over 1. I can cancel out the zeros. 12 into itself goes once. 12 into 36 goes 3. 3 into itself goes once. 3 into 12 goes 4. So we end up with 4 pi times 1 over 1, which is 4 pi. And to 2 decimal places again, we can do 4 times either 3.14 or shift pi 12.57 to 2 decimal places. In the last question, the specified arc is the major arc. So there are two ways of doing this. Either you can work out the length of the minor arc and then work out the circumference and subtract the two, or you can work out the major angle, which is 360 take away 150. So let's do it the first way first of all. If I work out the circumference, that's going to be pi times d, so pi times 14, which is 14 pi. And then if I work out the minor arc, that's going to be 150 over 360 times 14 pi. They cancel. 3 into 15 goes 5, 3 into 36 goes 12, 2 into 14 goes 7, 2 into 12 goes 6. So I end up with 5 times 7 pi, which is 35 pi, over 6. So I get 35 pi over 6. And then to work out the length of the major arc, I can just look at the difference. So I could do 14 pi, take away 35 pi over 6, and I can get a common denominator of 6. So if I multiply top and bottom of this first one by 6, 60, I get 84. 6 times 14 is 84. And that will then give me 84 pi, take away 35 pi, 70, 60, 50. I get 49 pi over 6. Yep, 49 pi over 6. And that gives me the length of the major arc. Another way I could do this is just look at the angle. So the major angle here is going to be 360 take away 150. So that's going to be 260, 210. So we could then do 210 out of 360 times by pi times 14. Same sort of thing. So 3 into 21 goes 7, 3 into 36 goes 12, and then 6, 7, and I get 7 times 7 pi over 6 times 1, which is just 49 pi over 6, which is exactly the same. And obviously the 2 decimal places, I could just put in this into my calculator. So 49 times pi over 6 equals, and I get 25.66 centimeters, or 25.66. Now let's have a look at some areas. So the idea with area is exactly the same. So here we have what we would call here is your minor sector, and then here is your major sector of the circle. And it's the same idea. To work out the area of a sector, so the minor sector that's shaded in yellow, we need to work out the fraction of the area that we have, which is theta over 360 times the area of the circle, which is pi r squared. So if we look at some examples here, so the first one, I want to find the area of the shaded part of the circle, which is the minor sector. So the angle is 30, so I need to do 30 over 360 times pi times 2 squared, and again I like to put that over 1. They cancel out. 3 into itself goes 1, 3 into 36 goes 12. Pi times 2 squared is 4 pi, so I end up with 4 pi over 12, which simplifies to pi over 3. And we can work out the 2 decimal places as follows. Let's put in shift pi over 3. And that gives me 1.05 to 2 decimal places. In the second question, the angle is 90. So I've got 90 over 360 times pi times 3 squared, which will give me 9 pi over 4, because 9 into itself goes 1, 9 to 36 goes 4, you get 9 pi over 4. And to 2 decimal places again, that's going to be 9 pi divided by 4, which is 7.07. And lastly, we need to do 120 over 360 times pi times 5 squared, which is, let's simplify those, 1 and 3. We end up with 25 pi over 3. So 25 times pi over 3 to 2 decimal places is going to be 26.18. And obviously these are square units. The last one, we want to work out the area of the major sector. So what we could do is either, as before, we could work out the area of the full circle. So that's going to be pi times 6 squared, which is 36 pi. Then work out the area of the minor sector. So 150 over 360 times pi times 6 squared, which we can work out, 5 over 12. That's going to be 5 pi times 36 over 12. 36 over 12 is going to be 3. So we end up with 15 pi. So to work out the area of the major sector, we do 36 pi, take away 15 pi. So 21 pi. Alternatively, you could use the major angle again. So that's going to be 210. And you could do 210 out of 360 times pi times 6 squared. So there you go. 21, 7, 12, 36. 36 over 12 is 3. 3, so you also get 21 pi. And obviously you can put it into your calculator and you'll get about 64 something. 21 times pi, not quite that actually. You'll end up with 65.97 to 2 decimal places. Be 65.97. Here are some questions for you to try. Please pause the video now and have a go. Can you give your answers in terms of pi? Here are the answers. We're now going to look at segments. If we have an arc of a circle or a sector of a circle, and then we draw a chord going from one end of the sector on the point on the circumference to the other end. There's our chord. We form a minor segment in blue, and in green, all of that is the major segment of the circle. You may be asked to find the area of a minor or major segment. And to do this, we simply work out the area of the triangle here using half AB sine C, and then subtract from the area of the sector. To find the area of the major sector, we just subtract the area of the minor, to find the area of the major segment, we subtract the area of the minor segment from the area of the circle. Here is an example. So, I want to find the area of the shaded segment, so that's the minor segment here. First thing I'm going to do is find the area of the sector AOB. So we use our method from before, theta over 360 times pi r squared. And then we work out the area of the triangle AOB. And then we can work out the area of the minor segment. So let's do this plan. So for the area of the sector AOB, I need to do 30 over 360 times pi times 5 squared. So that's going to be 1 out of 12, 25 pi over 12 centimeters squared. That's all of this area, the whole area of the sector. Then what I'm going to do is work out the area of the triangle AOB. So I can use half AB sine C. We have the included angle, the two smaller sides A and B, and we use half AB sine C. So that's going to be half times 5 times 5 times sine of 30. Sine 30 is a half, so we will end up with 25 over 4. If you put them into a calculator, you get 25 over 4, which is 6.25. So to work out the area of the minor segment, I just need to do 25 pi over 12, take away 25 over 4. And we can put them into a calculator, and this is what we should get. 25 pi over 12, take away 25 over 4. And we end up with an answer of 0.29 centimeters squared. Here's another example. We want to find the area of the shaded segment. So this is the major segment this time. To do this, I'm first going to find the area of the minor segment. So to do that, I'm going to do the area of the sector AOB. So that's going to be so that's going to be 30 over 360 times pi r squared. So pi times 5 squared, that's going to be 25 pi over 12, same as before. That's the area of the sector. The area of the triangle is going to be the same as before, half AB sine C, half times 5 times 5 times sine 30, which works out to be 25 over 4. And then we just take them away. So we have 25 pi over 12, take away 25 over 4. So we've done that already. It's about 0.29. It was, 0.29 we'll say. To work out, on centimeters squared, to work out the area of the full circle, we need to do pi r squared, pi times 5 squared, which is 25 pi. So to work out the area of the major segment, we need to do 25 pi, which is the whole circle, take away 0.29. And that will give me the answer to 2 decimal places. So if I just do 25 pi, take away what I just had, and I get 78.24 approximately. Here are some questions for you to try. Please pause the video now and have a go. I'd like you to find the area of the minor segment and then the area of the major segment. Here are the answers.